In Unreal Engine 5, docking windows is a great way to customize your workspace and improve your workflow. Here's how you can dock windows. Docking a window 1. Open a window. If the window you want to dock is not already open, you can open it from the Window menu at the top of the Unreal Engine interface. 2. Drag the window. Click and hold the Window's tab or title bar that you want to dock. Drag it to the area where you want to dock it. As you drag, you'll see highlighted docking zones within the editor interface. 3. Drop the window. When the window is over a valid docking zone, it will snap into place and show a preview of where it will be docked. Release the mouse button to drop the window in the desired location. Creating custom layouts. Floating windows. You can also have windows floating instead of docked. Just drag the window out of the docking zones and release it where you want it to float. Tabbed layouts. You can dock windows in the same area to create tabbed layouts. This is useful for having multiple tools or views in the same region of your screen, allowing you to switch between them quickly. Resetting the layout. Reset layout. If you ever need to reset your workspace layout to the default, you can do so by going to the Window menu and selecting Reset Layout. Saving and loading layouts. Save current layout. You can save your current layout for future use. Go to Window, Save Layout to save your current configuration. Load a saved layout. If you want to load a previously saved layout, go to Window, Load Layout, and select the layout you want to use. Practical tips. Optimizing workflow. Customize your layout based on your workflow. For instance, if you're frequently switching between the Content Browser, Details panel, and the Viewport, arrange them in a way that minimizes the amount of mouse movement and clicking needed. Multi-monitor setups. If you have multiple monitors, take advantage of the extra screen real estate by floating windows on different monitors. This can greatly increase your efficiency by keeping more tools and information visible at once. By docking windows and customizing your layout in Unreal Engine 5, you can create a more efficient and personalized workspace that suits your development needs. In Unreal Engine, the world settings are crucial for defining and customizing the environment and behavior of your game or project. Here's an introduction to the world settings and an overview of the key options available. Accessing world settings. To access the world settings in Unreal Engine 5, 1. Open your project. 2. Go to the main menu and select Window. 3. From the drop-down, select World Settings. This will open the World Settings panel. Key World Settings options. General Settings. World Gravity. Controls the gravitational force in your world. By default, it's set to Earth's gravity, but you can adjust it to create different effects, such as lower gravity for a moon-like environment. Kill Z. This is the Z-coordinate value below which actors are destroyed, useful for ensuring that objects falling out of the playable area are removed from the game. Game Mode. Game Mode Override allows you to specify a custom game mode for the current level. Game Mode determines the rules of the game, including the default pawn, player controller, and HUD. Player Controller class defines the default player controller for the game. The player controller manages input from the player and translates it into actions within the game. Default Pawn class sets the default character or pawn that players will control in the game. HUD class specifies the default HUD, heads-up display, class for the game, which is used to display information to the player, such as health, score, and inventory. Light mask settings. Static lighting. Static lighting level scale controls the scale of the level for light mask calculations. Smaller values result in more detailed lighting, but increase build times. Num indirect lighting bounces determines the number of times light is allowed to bounce off surfaces. More bounces create more realistic lighting but increase build times. Indirect lighting quality. Adjust the quality of indirect lighting. Higher values produce better quality lighting but require more processing time. Environment color. sets the color used for environmental lighting, which affects the overall color tone of the scene. World composition. Enable world composition. Allows the use of world composition, which is a system for managing large open-world maps. It divides the world into smaller sublevels, which can be streamed in and out based on the player's location. Distance streaming controls how sublevels are streamed in and out based on their distance from the player. Navigation settings. Navigation system configures settings for the navigation system, which is used for AI pathfinding. Rebuild at runtime allows the navigation mesh to be rebuilt at runtime, which is useful for dynamic environments. Physics settings. Enable async scene. Enables an asynchronous physics scene, which can improve performance by offloading physics calculations to a separate thread. Physics solver iterations. Adjust the number of iterations used by the physics solver. Higher values result in more accurate physics simulations, but can affect performance. Level streaming. Level streaming method specifies how levels are streamed in and out. Options include blueprint, always loaded, and manual. Async loading thread enabled enables asynchronous level loading, which can improve performance by loading levels in the background. Practical tips. Tailor settings to your project. Adjust the world settings based on the needs of your project. For example, lower gravity for space-themed games or enabling world composition for large open-world games. Optimize for performance. Balance quality and performance by tweaking settings like indirect lighting quality and static lighting level scale. Experiment and iterate. Don't be afraid to experiment with different settings. Use the play and editor mode to test changes quickly. By understanding and utilizing the world settings in Unreal Engine 5, you can create a more tailored and optimized environment for your game or project. Unreal Engine offers several types of default projects that cater to different kinds of games and applications. Each project type comes with pre-configured settings and assets tailored to specific genres or development goals. Here's an introduction to the various default project types available in Unreal Engine. Header 1. First person. Description. This project type is designed for first-person shooter FPS games, where the camera is positioned to simulate the player's viewpoint. Features. A pre-configured character with first-person camera and controls. Basic movement mechanics, walking, running, jumping. A basic shooting system with projectiles. 2. Third person. Description. Ideal for third-person action adventure games, where the camera follows the character from behind. Features. A pre-configured character with a third-person camera and controls. Basic movement mechanics, walking, running, jumping. Camera follow and rotation functionality. 3. Top-down. Description. Suitable for top-down games, where the camera is positioned above the character or scene. Features. A pre-configured character with top-down camera and controls. Basic movement mechanics using mouse or keyboard input, useful for strategy games, RPGs, and simulation games. 4. Side-scroller. Description. Designed for 2D side-scrolling games, similar to classic platformers. Features. A pre-configured character with side-scrolling camera and controls. Basic movement mechanics, walking, running, jumping. A 2D perspective with parallax backgrounds. 5. Vehicle. Description. Tailored for vehicle-based games, such as racing or driving simulators. Features. A pre-configured vehicle with realistic physics. Vehicle controls for acceleration, braking, and steering. Camera setup for following the vehicle. 6. Flying. Description. Ideal for flight simulators or games with aerial combat. Features. A pre-configured flying vehicle with flight physics. Basic flight controls for movement in all directions. Camera setup for following the flying vehicle. 7. VR. Virtual reality. Description. Designed for virtual reality applications and games. Features. Pre-configured VR setup with head-mounted display, HMD support, VR motion controller input and interaction. Optimized settings for VR performance and comfort. And head blank. Description. A blank project with minimal pre-configurations, offering maximum flexibility. Features. No pre-configured gameplay mechanics or assets. Ideal for custom projects or for developers who want to start from scratch. 9. AR Augmented Reality. Description: designed for augmented reality applications. Features: pre-configured AR setup with camera and tracking support. Basic interaction with AR elements. Optimized settings for AR performance. Practical tips for choosing a project type. Match your game genre. Choose a project type that closely matches the genre or style of your game to save time and effort on initial setup. Start with a template. If you're new to Unreal Engine or the specific type of game you're making, starting with a template can provide a good foundation. Customize as needed. Even if you start with a template, you can always customize and expand upon it to fit your specific needs and vision. Experiment with multiple types. Don't hesitate to experiment with different project types to see which one best suits your project goals. By understanding the different default project types in Unreal Engine, you can choose the best starting point for your game or application, allowing you to focus more on creating and less on configuring. The Content Drawer in Unreal Engine 5 is a central hub for managing your project's assets. It replaces the traditional content browser, providing a more streamlined and flexible way to access and organize your content. Here's an introduction to the Content Drawer and its key features. Accessing the Content Drawer. Opening the Content Drawer. To open the Content Drawer, click the Content Drawer button at the bottom of the Unreal Engine 5 interface or press Control Space. This will bring up the drawer, which slides up from the bottom of the screen. Key features of the Content Drawer. 1. Asset organization. Folders. You can create and organize assets into folders. Right-click in the Content Drawer and select New Folder to create a new folder. Drag and drop assets into these folders for better organization. Collections. Collections allow you to group assets together without moving them from their original folders. This is useful for grouping related assets across different directories. Header 2. Asset management. Importing assets. To import new assets, click the Import button or drag and drop files directly into the Content Drawer. This supports various asset types, including 3D models, textures, audio files, and more. Creating assets. Right-click in the Content Drawer to create new assets, such as materials, blueprints, animations, and more. This provides a quick way to generate new content directly within the drawer. 3. Search and filter. Search bar. The search bar at the top of the Content Drawer allows you to quickly find assets by name. Type in keywords to filter the displayed assets. Filters. Use the filter options to narrow down your search results based on asset type, tags, or other criteria. This helps in locating specific assets quickly, especially in large projects. 4. Thumbnail and list views. View modes. You can switch between different view modes, such as thumbnail view and list view, to see your assets in the preferred format. Thumbnail view provides visual previews, while list view offers detailed information. Adjustable thumbnails. Adjust the size of thumbnails to get a better view of your assets. Use the slider at the bottom right of the Content Drawer to resize thumbnails. 5. Asset details and metadata. When an asset is selected, the Details panel provides comprehensive information and editable properties for that asset. This includes metadata, file paths, and specific settings depending on the asset type. Asset metadata. You can add custom metadata to assets, such as tags or notes, to improve organization and searchability. How 6. Quick access and docking. Pinned favorites. Pin frequently used folders or collections to the top of the Content Drawer for quick access. Right-click on a folder or collection and select Pin to Favorites. Docking options. The Content Drawer can be docked like other windows in Unreal Engine. Drag the Content Drawer tab to dock it in a specific area of the interface for a more permanent view. Practical tips. Efficient organization. Organize your assets logically with a clear folder structure. Use consistent naming conventions to make finding assets easier. Utilize collections. Use collections to group assets for specific purposes, such as a level design set or character assets, without changing their folder locations. Regular cleanup. Periodically clean up unused or redundant assets to keep your project organized and reduce clutter. Customize views. Customize the view settings to match your workflow preferences. Adjust thumbnail sizes and switch between views as needed. By effectively utilizing the content drawer in Unreal Engine 5, you can streamline your workflow, keep your project organized, and quickly access the assets you need for development. In Unreal Engine, actors are one of the most fundamental concepts. They represent any object that can be placed in a level, ranging from characters and props to lights and cameras. Here's an introduction to actors and their key components. Shah? What is an actor? An actor is a base class for an object that can be placed or spawned in a level. It encapsulates a variety of behaviors and properties, making it a versatile building block for your game or application. Hat. Types of actors. There are several types of actors in Unreal Engine, each serving different purposes. 1. Static mesh actor, used for static geometry such as buildings, furniture, or any non-moving object. 2. Skeletal mesh actor, used for characters or any object that requires animation through a skeletal mesh. 3. Camera actor, represents a camera in the scene. It can be used for cinematic sequences or to control the player's view. 4. Light actor, includes various types of lights, e.g. directional, point, spot, to illuminate the scene. 5. Volume actor, defines areas with specific behaviors or properties, such as trigger volumes or post-processing volumes. 6. Pawn, represents any controllable character or vehicle. It can be possessed by a player controller. 7. Character, a specialized type of pawn that includes additional functionality for movement, collision, and animation. 8. Blueprint actor, a custom actor created using the Blueprint visual scripting system, allowing for complex behaviors without writing code. Key components of an actor. Actors can have various components attached to them, which define their appearance and behavior. 1. Components. Components are the building blocks of actors. Common components include static mesh component, skeletal mesh component, camera component, and more. 2. Transform. Every actor has a transform, which includes its location, rotation, and scale in the world. 3. Properties. Actors have a variety of properties that can be adjusted in the Details panel, such as visibility, collision settings, and more. 4. Events. Actors can respond to events, such as overlap events, input events, or custom events defined in blueprints. Creating and using actors. Placing actors in a level. Drag and drop. You can place actors into your level by dragging them from the content drawer or the modes panel into the viewport. Transform manipulation. Once placed, you can manipulate an actor's transform using the move, rotate, and scale tools in the viewport. Shashar spawning actors at runtime. Blueprints. You can spawn actors dynamically using blueprints. Use the spawn actor from class node to create new instances of an actor at runtime. C++. In C++, you can use the spawn actor method to spawn actors programmatically. Interacting with actors. Blueprints. Use blueprints to define interactions with actors, such as opening a door when a player enters a trigger volume. Components and events. Attach components to actors and bind events to create interactive behaviors, like making a light turn on when an actor is clicked. Practical tips. Use blueprints for prototyping. Blueprints are a powerful tool for quickly creating and testing actors without needing to write code. Optimize actor usage. Minimize the number of actors in your level to optimize performance. Use instancing or hierarchical instance static meshes for repeated objects. Organize actors. Group related actors into sublevels or use folders in the world outliner to keep your scene organized. Leverage components. Break down complex actors into reusable components to keep your project modular and maintainable. By understanding and effectively using actors in Unreal Engine, you can build a wide variety of objects and behaviors, creating a rich and interactive environment for your game or application. Static meshes in Unreal Engine are essential building blocks for creating detailed and optimized 3D environments. They represent non-moving, static meshes in Unreal Engine are essential building blocks for creating detailed and optimized 3D environments. They represent non-moving, static 3D geometry that can be used for a variety of purposes, from environment art to props and architectural elements. Here's an introduction to static meshes and their key features. What is a static mesh? A static mesh is a 3D model that consists of polygons and vertices representing the shape and structure of an object. Static meshes in Unreal Engine are essential building blocks for creating detailed and optimized 3D environments. They represent non-moving, static 3D geometry that can be used for a variety of purposes, from environment art to props and architectural elements. Here's an introduction to static meshes and their key features. What is a static mesh? A static mesh is a 3D model that consists of polygons and vertices representing the shape and structure of an object. Unlike skeletal meshes, static meshes do not have bones or animations, making them ideal for static objects in your scene. Key features of static meshes. 1. Importing static meshes. Supported formats. Unreal Engine supports several 3D file formats, such as FBX and OBJ, for importing static meshes from external 3D modeling software like Blender, Maya, or 3ds Max. Import process. To import a static mesh, go to the Content drawer, click the Import button, and select your 3D model file. You can also drag and drop files directly into the Content drawer. 2. Static mesh components. Static mesh component. When you add a static mesh to an actor, it is represented by a static mesh component. This component handles rendering, collision, and other properties related to the mesh. Transform properties. Static mesh components have transform properties, location, rotation, scale that determine their position and orientation in the world. Letter 3. Material and texture assignment. Materials. Static meshes can have one or more materials assigned to them. Materials define the appearance of the mesh, including its color, texture, and other surface properties. UV mapping. UV mapping coordinates are used to apply textures correctly to the surface of the mesh. Ensure your 3D model has proper UVs before importing. 4. Collision settings. Collision primitives. Static meshes can have collision primitives, boxes, spheres, capsules, automatically generated or custom collision meshes imported. These are used to detect interactions with other objects. Adjust the collision complexity settings to balance accuracy and performance. Options include simple and complex collision. 5. LOD level of detail. Static meshes can have multiple LODs, which are simpler versions of the mesh used when the object is far from the camera. This helps optimize performance by reducing the number of polygons rendered. Auto-generation. Unreal Engine can automatically generate LODs for your static meshes, or you can create and import custom LODs. 6. Instancing. Instance static meshes use instance static mesh components to render large numbers of the same mesh efficiently. This is useful for objects like trees, rocks, or any repeated geometry. Hierarchical instance static meshes. This component provides additional optimizations for hierarchical transformations, ideal for complex scenes with many instances. Creating and using static meshes. Placing static meshes in a level. Drag and drop. Place static meshes into your level by dragging them from the Content drawer into the viewport. You can position, rotate, and scale them using the transform tools. Static Mesh Editor. Accessing the editor. Double-click a static mesh asset in the Content drawer to open the Static Mesh Editor. This editor allows you to adjust various properties and settings of the mesh. Editing properties. Use the Static Mesh Editor to modify collision settings, LODs, materials, and other properties. The preview window lets you see changes in real time. Practical tips. Optimize meshes. Keep your meshes optimized for performance by reducing polygon count and using LODs effectively. Consider using normal maps to add detail without increasing geometry complexity. Organize assets. Organize your static mesh assets into folders in the content drawer to keep your project structured and easy to navigate. Reuse assets. Reuse static meshes across different levels and projects to save time and resources. Use instancing to efficiently manage repeated objects. Check UVs. Ensure your 3D models have proper UV mapping for accurate texture application. Overlapping or missing UVs can cause texture issues. By understanding and effectively using static meshes in Unreal Engine, you can create detailed and optimized 3D environments, enhancing the visual quality and performance of your projects. In Unreal Engine, materials and material instances are fundamental for defining the appearance of surfaces in your game or application. They control how objects interact with light and how they appear to the player. Here's an introduction to materials and material instances. What is a material? A material in Unreal Engine is a collection of properties and settings that define the visual appearance of a surface. It describes how a surface interacts with light. In Unreal Engine, materials and material instances are fundamental for defining the appearance of surfaces in your game or application. They control how objects interact with light and how they appear to the player. Here's an introduction to materials and material instances. What is a material? A material in Unreal Engine is a collection of properties and settings that define the visual appearance of a surface. It describes how a surface interacts with light, including its color, texture, shininess, transparency, and more. Key features of materials. 1. Material Editor. Accessing the Material Editor. To create or edit a material, double-click a material asset in the content drawer. This opens the Material Editor, a node-based interface for creating complex material effects. Node-based system. The Material Editor uses a node-based system where you connect different nodes to define the material's properties. This allows for a high degree of customization and flexibility. 2. Material Properties, Base Color, defines the base color of the material. You can use a constant color or a texture map to provide color information. Metallic controls how metallic the surface appears. A value of 1 makes the surface fully metallic, while 0 makes it non-metallic. Specular adjusts the intensity of specular highlights. It influences how shiny the surface appears. Roughness determines the roughness of the surface. Lower values result in a smoother, shinier surface, while higher values create a rougher, more matte finish. Normal uses a normal map to add fine surface details without increasing the polygon count. Normal maps create the illusion of bumps and dents on the surface. Emissive defines the color and intensity of light emitted by the material, useful for creating glowing objects. Opacity controls the transparency of the material. A value of 1 is fully opaque, while 0 is fully transparent. Refraction simulates the bending of light as it passes through the material, useful for glass or water surfaces. 3. Textures and maps. Texture maps. Textures are 2D images applied to the surface of a material. Common texture maps include base color, normal, roughness, metallic, and emissive. UV mapping. UV coordinates determine how textures are applied to the 3D surface. Proper UV mapping is essential for accurate texture placement. What is a material instance? A material instance is a variation of a base material that allows you to change certain properties without duplicating the entire material. This is useful for creating variations of a material while maintaining a single base material for easy management and optimization. Key features of material instances. 1. Creating material instances. Instance creation. To create a material instance, right-click a base material in the content drawer and select Create Material Instance. This creates an instance that inherits properties from the base material. Parameter overrides. Material instances allow you to override specific parameters of the base material, such as color, roughness, and texture maps. These parameters are defined in the base material as material instance parameters. 2. Performance and flexibility. Optimization. Using material instances helps optimize performance by reducing the number of unique materials that need to be processed by the engine. Instances share the same shader code as the base material. Consistency. Material instances ensure consistency across similar materials. Changes to the base material automatically propagate to all instances. 3. Dynamic changes, dynamic parameters. Material instances can be dynamically changed at runtime using blueprints or C++. This allows for interactive materials that respond to game events, such as changing colors or textures. Practical tips: use material instances. Always use material instances for variations of a material to optimize performance and maintain consistency. Organize materials. Keep your materials and instances organized in the content drawer using folders and naming conventions. Experiment with nodes. Experiment with different nodes and combinations in the material editor to create unique and visually appealing materials. Optimize textures. Use appropriately sized textures to balance quality and performance. Consider using texture atlases to reduce the number of texture lookups. By understanding and effectively using materials and material instances in Unreal Engine, you can create rich and visually compelling environments that enhance the overall experience of your game or application. Lighting is a critical aspect of creating realistic and visually appealing scenes in Unreal Engine. It not only affects the overall look and feel of your environment, but also plays a significant role in performance and gameplay mechanics. Here's an introduction to lighting in Unreal Engine, covering the key concepts, types of lights, and essential settings. Key concepts in Unreal Engine lighting. 1. Types of lighting. Direct lighting. This is the light that travels directly from a light source to an object, creating sharp shadows and highlights. Indirect lighting. Also known as bounced light, it is the light that reflects off surfaces before hitting an object, creating softer shadows and a more natural appearance. Dynamic lighting. Dynamic lights can change in real time and are used for moving objects or lights that need to change during gameplay. Static lighting. Static lights are pre-calculated and baked into the scene. They are more performance-friendly, but do not change in real time. Stationary lighting. Stationary lights are a hybrid of static and dynamic lights. They can cast dynamic shadows from moving objects, but have static shadows for static geometry. Types of lights in Unreal Engine. 1. Directional light. Description: simulates sunlight or moonlight. It emits parallel light rays, making it ideal for outdoor scenes. Key properties: intensity, controls the brightness of the light, sets the color of the light. Cast shadows, determines whether the light casts shadows. 2-point light. Description: emits light in all directions from a single point, similar to a light bulb. Suitable for small localized light sources. Key properties: controls the brightness. Attenuation radius, defines the distance at which the light affects objects. Fall off, determines how the light intensity decreases with distance. 3. Spotlight. Description: emits light in a cone shape, similar to a flashlight, ideal for focused light sources like street lamps. Key properties: intensity, controls the brightness. Inner cone angle, the angle of the fully lit cone. Outer cone angle, the angle of the partially lit cone. Rect light. Description: emits light from a rectangular area, useful for simulating large area light sources like windows or fluorescent lights. Key properties: intensity, controls the brightness. Source width height, defines the dimensions of the light source. Hatter 5, skylight, captures the ambient light in the scene and applies it globally. It's used for lighting scenes with indirect light from the sky. Intensity, controls the brightness. Source type can be set to SLS captured scene or SLS specified cube map. Lighting settings and techniques. 1. Light mask. Description: Light mask is Unreal Engine's global illumination solver. It calculates indirect lighting and bakes it into the scene. Settings: static lighting level scale, controls the detail of baked lighting. Num indirect lighting bounces, sets the number of times light bounces off surfaces. Environment color defines the color of ambient lighting in the scene. Neher 2. Light mobility. Static baked lighting with no runtime cost, best for non-moving lights. Stationary. Allows for dynamic shadows from moving objects while keeping baked shadows for static objects. Good for lights that might change intensity or color. Movable. Fully dynamic lighting and shadows. Ideal for moving lights but with a higher performance cost. 3. Shadow settings. Cast shadows. Determines if the light casts shadows, can be enabled or disabled per light. Shadow quality. Adjusts the quality and resolution of shadows. Contact shadows. Adds finer shadow details for close-up objects. 4. Post-processing. Global illumination. Enhances the overall lighting realism by adding indirect lighting. Ambient occlusion simulates the soft shadows that occur in corners and crevices where light is occluded. Bloom creates a glow effect around bright areas, adding to the realism. Practical tips. Balance lighting and performance. Use a combination of static, stationary, and movable lights to balance visual quality and performance. Use light probes. Light probes can help in providing realistic lighting for dynamic objects. Optimize light map resolution. Adjust light map resolutions for objects to balance between detail and performance. Experiment with lighting scenarios. Test different lighting setups and scenarios to see how they affect the mood and readability of your scene. By understanding and effectively utilizing these lighting tools and techniques in Unreal Engine, you can create visually stunning and performance-optimized environments for your games and applications. Blueprints in Unreal Engine are a powerful visual scripting system that allows developers to create gameplay elements, interactive environments, and complex behaviors without writing a single line of code. Blueprints offer a user-friendly way to prototype and implement functionality quickly, making them an essential tool for both novice and experienced developers. Here's an introduction to blueprints. What are blueprints? Blueprints are a form of visual scripting that uses a node-based interface to create and manage gameplay elements. They are a part of Unreal Engine's overarching system for programming, which also includes C++. Blueprints allow you to connect various nodes, which represent different functions, variables, and events, to create logical flows and interactions. Types of blueprints. There are several types of blueprints, each serving different purposes. 1. Blueprint class. This is the most common type of blueprint, used to create new classes of objects. Blueprint classes can be anything from a character, a weapon, to a custom game mechanic. 2. Level blueprint. Each level in Unreal Engine has its own level blueprint, which is used to control level-specific events and interactions. This is ideal for scripting level sequences, managing level transitions, and setting up initial conditions. 3. Blueprint interface. Blueprint interfaces define a set of functions that other blueprints can implement. They are used to ensure different blueprints can communicate with each other without needing to know their specific implementation details. 4. Blueprint function library. This contains a collection of reusable functions that can be called from other blueprints. Function libraries are useful for organizing and reusing common functionality across your project. Key features of blueprints. 1. Visual scripting interface. Node-based system. Blueprints use a node-based system where you connect nodes to create logic. Each node represents a function, event, or variable. Graph editor. The main interface for working with blueprints is the graph editor. This is where you create and connect nodes to define behavior. 2. Variables and data types. Variables. Blueprints support various types of variables, such as integers, floats, booleans, vectors, and more. Variables store data that can be used and manipulated within your blueprints. Arrays and structs. Blueprints also support arrays, collections of elements, and structs, custom data structures, to organize and manage data more effectively. 3. Functions and events. Functions. Functions are reusable blocks of logic that can be called from different parts of your blueprint. They help organize your blueprint and reduce code duplication. Events. Events are nodes that respond to specific actions or conditions, such as player input, collisions, or timers. They are the starting points for many blueprint scripts. Flow control. Execution flow. Blueprints use execution flow nodes to control the order in which actions are performed. Common flow control nodes include sequence, branch, if statements, for loops, and while loops. Timelines. Timelines are special nodes used to create animations and interpolate values over time, making them ideal for creating smooth transitions and animations. HANA 5. Components and actors. Components. Blueprints can manage various components, such as meshes, cameras, and audio sources, to build complex actors. Components are added and configured within the blueprint editor. Actor blueprints. Actor blueprints are blueprints that can be placed in the world. They encapsulate both logic and components, making them versatile for creating interactive objects. Creating and using blueprints. Creating a blueprint class. New blueprint. To create a new blueprint class, right-click in the content browser, select Blueprint Class, and choose a parent class, such as Actor or Character. Editing the blueprint, double-click the blueprint to open it in the Blueprint Editor. Here you can add components, create variables, and define behavior using the Graph Editor. Hashtag 2. Setting up events and logic. Event Graph. The event graph is where you define the behavior of your blueprint. Add event nodes, e.g. begin play, tick, on overlap to respond to gameplay events. Connecting nodes. Drag from the output pin of one node to the input pin of another to create connections and define the flow of execution. Hasher 3. Debugging blueprints. Breakpoints and watches. Use breakpoints and watches to debug your blueprints. Right-click on a node and select Add Breakpoint to pause execution and inspect variable values. Print strings. Use print string nodes to output text to the screen or log, helping you track the flow of execution and variable values. Practical tips. Use comments and reroute nodes. Organize your blueprints with comments and reroute nodes to keep them readable and maintainable. Modular design. Break down complex logic into smaller, reusable functions and macros to keep your blueprints organized. Performance considerations. Avoid heavy computations in the tick event. Use timers and event-driven logic where possible to optimize performance. Blueprint to C++. Start with blueprints for rapid prototyping, and consider converting performance-critical blueprints to C++ as your project matures. By understanding and effectively using blueprints in Unreal Engine, you can create complex gameplay mechanics and interactive environments quickly and efficiently without needing deep programming knowledge. In Unreal Engine, widgets are used to create user interfaces, UI, for your game or application. These interfaces can include menus, HUDs, heads-up displays, in-game controls, and more. Widgets are part of the Unreal Motion Graphics UMG UI Designer, which provides a powerful and flexible framework for building complex and interactive UIs. Here's an introduction to widgets in Unreal Engine. What are widgets? Widgets are the building blocks of UIs in Unreal Engine. They are visual elements that can display information or interact with the player. Each widget has its own properties, functions, and events that can be customized to create dynamic and responsive interfaces. Key features of widgets. 1. Types of widgets. Basic widgets, button, a clickable button. Text block, displays a line of text. Image, displays an image. Slider, a draggable slider for numeric input. Checkbox, a box that can be checked or unchecked. Progress bar, displays a progress indicator. Container widgets. Canvas panel, a flexible container for positioning widgets using absolute coordinates. Horizontal box, lays out child widgets horizontally. Vertical box, lays out child widgets vertically. Grid panel, arranges child widgets in a grid. Overlay, stacks widgets on top of each other. Complex widgets. List view, displays a list of items. Scroll box, provides a scrollable area. Editable text, allows text input. Rich text block, displays text with formatting. 2. Widget Blueprint. Creating widget blueprints. To create a new widget, right-click in the content browser, select User Interface, Widget Blueprint, and give it a name. Double-click the widget blueprint to open it in the Widget Designer. Widget Designer. The Widget Designer is where you visually design your UI. You can drag and drop widgets from the palette panel onto the design canvas and arrange them as needed. Number 3. Properties and Styling. Properties Panel. The Properties panel allows you to configure the properties of selected widgets, such as size, position, color, and text. Styling. Widgets can be styled using the Style section in the Properties panel. You can change fonts, colors, images, and other visual aspects to match your game's aesthetic. 4. Binding and Dynamic Content. Data binding. Bind widget properties to variables or functions to make the UI dynamic. For example, you can bind a text block to display the player's score, which updates in real time. Animations. Create animations for widgets using the Animation tab in the Widget Designer. You can animate properties like position, size, opacity, and color to create engaging UI effects. Creating and using widgets. 1. Designing a widget. Adding widgets. Drag and drop widgets from the palette onto the design canvas. Arrange and resize them as needed. Setting properties. Select a widget and use the Properties panel to configure its settings, such as text content, alignment, padding, and styling. 2. Implementing widget logic. Event graph. Use the event graph to add functionality to your widgets. This is similar to the Blueprint scripting system. You can handle events like button clicks, text changes, and more. Binding data. Bind widget properties to variables or functions to display dynamic content. For example, bind a health bar's progress to the player's health variable. Adding widgets to the viewport. Creating a HUD. To display a widget in your game, you typically add it to the viewport. This is done in a blueprint, e.g., player controller, game mode, using the Create Widget node. Adding to viewport. Use the Add to Viewport node to display the widget on the screen. This node is usually called after creating the widget instance. Practical tips. 1. Organize widgets. Naming conventions. Use clear and consistent naming conventions for your widgets and their components to keep your project organized. Hierarchy. Use container widgets, e.g., canvas panel, vertical box, to group related widgets and manage their layout efficiently. 2. Optimize performance. Visibility. Set widget visibility appropriately to avoid rendering unnecessary widgets. Use set visibility nodes to show or hide widgets based on game state. Tick optimization. Minimize the use of tick events in widgets. Use events and data binding to update widgets only when necessary. 3. Debugging and testing. Print strings. Use print string nodes in the event graph to debug widget behavior and check values during gameplay. Test responsiveness. Test your UI at different screen resolutions and aspect ratios to ensure it remains responsive and looks good on all devices. By understanding and effectively using widgets in Unreal Engine, you can create intuitive and interactive user interfaces that enhance the player experience and provide essential game information. In Unreal Engine, animation is a crucial aspect of bringing characters, objects, and environments to life. The engine provides a comprehensive suite of tools and systems for creating and managing animations, from simple object movements to complex character animations. Here's an introduction to animation in Unreal Engine. What is animation in Unreal Engine? Animation in Unreal Engine involves the process of creating and controlling movement and transformations of objects and characters. This includes animating characters' skeletal structures, manipulating object positions, and creating complex sequences of movement. Key concepts in Unreal Engine animation. 1. Types of animation. Skeletal animation, used for animating characters with a bone structure. It involves creating animations that move the bones of a skeleton, which in turn moves the mesh attached to it. Vertex animation. Animates individual vertices of a mesh directly, often used for facial expressions or other detailed animations. Transform animation animates the position, rotation, and scale of objects. Useful for moving props, vehicles, or any object that needs to change its location or orientation. Animation assets. Animation sequence. A series of frames that define how a skeletal mesh moves over time. It's the core asset for playing animations on characters. Animation montage. A container for multiple animation sequences used to create complex animation blends and interruptions, often used for combat systems or advanced character animations. Animation blueprint. A specialized blueprint for controlling animations. It uses a state machine and blend nodes to define how different animations transition and blend based on game logic. Blend space allows for blending between multiple animations based on input parameters, such as blending between walking and running animations. 3. Animation systems. Skeletal mesh component. A component that represents a character or object with a skeleton. It can be used to play animations on a mesh. Animation blueprint manages the state and transitions of animations for a character or object. It uses a visual scripting interface to define how animations should be blended and played. Animation state machine. A system within the animation blueprint that manages the transitions between different animation states, e.g., idle, walk, run, jump. Pose asset. A collection of poses for a skeletal mesh, which can be used to create animations or adjust poses in real time. Creating and using animations. 1. Creating animation sequences. Importing animations. Import animation data from external tools, e.g. Maya, Blender, in formats like FBX. Unreal Engine will create animation sequences from this data. Editing animation sequences. Open an animation sequence asset to view and edit the animation. Use the animation editor to preview and adjust keyframes, curves, and playback settings. Creating animation blueprints. Creating an animation blueprint, right-click in the content browser, select Animation, Animation Blueprint, and choose a skeleton. This creates an animation blueprint that controls animations for that skeleton. Setting up state machines. In the animation blueprint, use the animation graph to create a state machine. Define different states, e.g., idle, walk, run, and transitions between them. Adding blend spaces. Create and configure blend spaces to blend between animations based on parameters like speed or direction. Add these blend spaces to your animation blueprint to create smooth transitions. 3. Using animation montages. Creating an animation montage. Right-click in the content browser, select Animation, Animation Montage, and choose an animation sequence. This allows you to combine multiple animations and create complex sequences. Configuring montages, use the montage editor to arrange animation sections, add notifies, and set up blend and transition rules. Montages are useful for handling complex actions like attacks or special moves. 4. Implementing animations in blueprints. Playing animations. Use the Play Animation node in blueprints to trigger animations. This can be done in response to events or player input. Controlling animation states. Use the setAnim instance class node to assign an animation blueprint to a skeletal mesh component. Control animation states and transitions through the animation blueprint's exposed functions. Practical tips. 1. Optimize animation performance. Reduce keyframes. Use fewer keyframes where possible to optimize performance. Unreal Engine can interpolate between keyframes to create smooth animations. Animation compression. Apply compression settings to reduce the size of animation data without significant loss of quality. 2. Use animation notifies. Add notifies. Use animation notifies to trigger events at specific frames in an animation, such as playing sound effects or spawning particles. Create custom notifies. You can create custom animation notifies to handle specific actions or gameplay events tied to animations. 3. Test new animations. Use the animation editor's preview feature to test animations in real time and adjust settings as needed. Iterate and refine. Continuously test animations in the context of your game to ensure they look and feel right. Adjust timing, blending, and transitions to achieve the desired result. By understanding and effectively utilizing animation tools and systems in Unreal Engine, you can create compelling and dynamic animations that enhance the visual and interactive quality of your game or application. Rendering in Unreal Engine refers to the process of generating the final visual output of a scene or level, converting 3D models, textures, lights, and effects into a 2D image or series of images for display on screen. It involves a complex pipeline of operations that transform raw scene data into the final visual presentation seen by the player. Here's an introduction to rendering in Unreal Engine. What is rendering? Rendering is the process of calculating how a scene's geometry, material. Rendering in Unreal Engine refers to the process of generating the final visual output of a scene or level, converting 3D models, textures, lights, and effects into a 2D image or series of images for display on screen. It involves a complex pipeline of operations that transform raw scene data into the final visual presentation seen by the player. Here's an introduction to rendering in Unreal Engine. What is rendering? Rendering is the process of calculating how a scene's geometry, materials, lighting, and effects are transformed into a 2D image. It involves multiple stages, including scene setup, shading, and post-processing, to produce the final visual output. Key concepts in rendering. Render pipeline. The rendering pipeline in Unreal Engine includes several stages, each responsible for a different aspect of image generation. Scene setup involves loading and positioning all the assets in the scene, including meshes, textures, lights, and cameras. Geometry processing converts 3D models into a format suitable for rendering, including vertex transformations and applying textures. Shading applies materials and shaders to the geometry. Shaders control how surfaces interact with light and how they appear visually. Lighting and shadows calculates how light interacts with the scene, including direct and indirect lighting, shadowing, and global illumination. Post-processing applies final image effects such as bloom, depth of field, and color grading to enhance the visual quality of the rendered image. Step 2. Rendering techniques. Forward rendering renders each object in the scene one by one, applying lighting and shading per object. It's simpler but can be less efficient with many lights. Deferred rendering renders the scene in multiple passes, first creating a G buffer that stores information about geometry and lighting, then applying lighting in a separate pass. It's more efficient with complex lighting scenarios, but can be more demanding on memory. Ray tracing, a technique for simulating realistic lighting by tracing rays of light as they travel through the scene. It offers high-quality reflections, refractions, and shadows, but requires significant computational power. Core rendering features. 1. Lighting. Types of lights. Directional light simulates sunlight or moonlight with parallel light rays. Point light emits light in all directions from a single point, like a light bulb. Spotlight emits light in a cone shape, similar to a flashlight. Skylight provides ambient lighting by capturing the scene's environment. Shadowing, static shadows, pre-computed and baked into the scene, ideal for non-moving objects. Dynamic shadows, calculated in real time for moving objects and lights, can be more performance-intensive. Contact shadows adds fine shadow details close to objects. Number 2, materials and shaders. Materials define the appearance of surfaces, including their color, texture, and interaction with light. Materials are created using the material editor, which uses a node-based system. Shaders, programs that run on the GPU to determine how materials should be rendered. Shaders handle complex visual effects like reflections, refractions, and surface details. 3. Post-processing. Effects. Creates a glow effect around bright areas. Depth of field blurs distant objects to simulate camera focus. Color grading adjusts the color balance and contrast of the final image. Volume settings. Post-processing volumes can be placed in the scene to apply effects within a specific area or across the entire level. 4. Render targets. Textures used to store the output of a render pass. They can be used for effects like reflections, shadows, or dynamic textures. 5. Optimization. Level of detail adjusts the complexity of models based on their distance from the camera to improve performance. Culling. Techniques to avoid rendering objects not visible to the camera, such as frustum culling and occlusion culling. Texture streaming manages texture memory usage by loading and unloading textures based on their visibility and importance. Setting up rendering in Unreal Engine. 1. Configuring quality settings. Scalability settings. Adjust overall quality settings to balance performance and visual fidelity. This includes options for texture quality, shadow quality, and more. Render settings. Access settings like anti-aliasing, resolution scale, and frame rate limits in the project settings under the rendering section. 2. Using the rendering features. Post-process volumes. Add post-process volumes to your scene to apply specific visual effects and adjustments. Lighting setup. Configure different types of lights and their properties to achieve the desired look and feel for your scene. Material creation. Use the Material Editor to create and customize materials and shaders for your assets. Practical tips. 1. Test performance. Profile rendering. Use Unreal Engine's profiling tools to analyze performance and identify bottlenecks in the rendering pipeline. Optimize assets. Ensure textures, models, and materials are optimized for performance to maintain smooth frame rates. 2. Experiment with techniques. Try different rendering techniques. Experiment with forward rendering, deferred rendering, and ray tracing to see which works best for your project's needs. Utilize community resources. Take advantage of tutorials, forums, and documentation to learn more about advanced rendering techniques and best practices. By understanding and effectively utilizing rendering features in Unreal Engine, you can create visually stunning and performant experiences that enhance the overall quality of your game or application. If you're new to Unreal Engine 5 and encounter errors while developing your game, it's important to know how to handle these issues efficiently. Here's a beginner-friendly guide on what to do if your game gives an error, including tips on saving, backups, and debugging. 1. Understanding and fixing errors. Common types of errors. Compilation errors. Occur when there are issues with code or blueprints that prevent them from compiling successfully. If you're new to Unreal Engine 5 and encounter errors while developing your game, it's important to know how to handle these issues efficiently. Here's a beginner-friendly guide on what to do if your game gives an error, including tips on saving, backups, and debugging. Understanding and fixing errors. Common types of errors. Compilation errors. Occur when there are issues with code or blueprints that prevent them from compiling successfully. Runtime errors happen during gameplay and can cause crashes or unexpected behavior. Editor errors appear within the Unreal Editor, often related to asset loading or editor settings. Steps to fix errors. Read the error message. Carefully read the error message provided. It usually gives clues about what went wrong and where the issue occurred. Error messages often include a line number or a reference to a specific asset or blueprint. Check the output log. The output log in Unreal Engine shows detailed information about errors and warnings. Access it via Window, Developer Tools, Output log. Look for errors listed in red text and investigate their details. Search online. Use error codes or messages to search for solutions online. The Unreal Engine documentation, forums, and community sites like AnswerHub or Stack Overflow can be helpful. Revert changes. If you recently made changes that might have caused the error, try reverting those changes. This helps isolate whether the error is due to recent modifications. Check dependencies. Ensure all required assets and dependencies are properly linked and up to date. Missing or broken links can cause errors. Update Unreal Engine. Make sure you are using the latest version of Unreal Engine 5. Updates often include bug fixes and improvements. How to saving and backups. Regular saving. Save often. Regularly save your work to avoid losing progress. Use File Save All to save changes across all open assets and blueprints. Save As. When making significant changes, use File Save As to create a new version of your project. This helps prevent overwriting important work. Creating backups. Manual backups. Periodically create manual backups of your project folder. Copy the entire project directory to an external drive or cloud storage service. Version control systems. Use version control systems like Git or Perforce. These tools track changes to your project and allow you to revert to previous versions if needed. Automated backups. Configure automated backups using tools like Unreal Engine's built-in cloud saving or third-party backup solutions. 3. Debugging. Debugging blueprints. Breakpoints. Set breakpoints in blueprints to pause execution at specific points and inspect variable values. Right-click on a node and select Add Breakpoint. Print strings. Use print string nodes to output debug information to the screen or log. This helps track variable values and the flow of execution. Watch variables. Use the Watch feature to monitor variables and their values in real time while debugging blueprints. Debugging C++ code. Debug build. Build your project in debug mode to include additional debugging information. This allows you to step through code and inspect variables. Breakpoints and step through. Set breakpoints in your code and use the debugger to step through execution line by line. This helps identify where issues occur. Log output. Use UE log statements in your code to output debug information to the output log. This is useful for tracking code execution and identifying issues. Using the editor's debugging tools profiling tools. Use Unreal Engine's profiling tools, such as stat commands, e.g. stat FPS, stat memory, to monitor performance and identify bottlenecks. Crash Reporter. If Unreal Engine crashes, the Crash Reporter can provide information about the crash and help identify the cause. Make sure to report crashes to help improve the engine. Testing and validation. Playtesting. Regularly playtest your game to identify and fix errors. Playtesting helps catch runtime issues and ensures that gameplay functions as expected. Validation tools. Use Unreal Engine's built-in validation tools to check for issues like asset errors, invalid references, or script problems. Summary. 1. Handling errors. Read error messages carefully. Check the output log. Search online for solutions. Revert recent changes if necessary. Ensure all dependencies are correct. Keep Unreal Engine updated. 2. Saving and backups. Save your work frequently. Use Save As for significant changes. Create manual backups and use version control. Set up automated backups if possible. 3. Debugging. Use blueprints, breakpoints, print strings, and variable watches. For C++ code, use breakpoints, step-through debugging, and log output. Utilize Unreal Engine's profiling and debugging tools. Regularly playtest and validate your game. By following these practices, you can effectively manage and resolve errors, protect your work, and ensure a smoother development process in Unreal Engine 5. I hope this tutorial has broadened your knowledge of Unreal Engine. If you found it helpful, please subscribe, like, and share. Enjoy your journey with Unreal Engine.